when you're doing trig equations, usually we just say solve for the variable omega in the range 0 to 2 pi or 0 to 4 pi or something like that. But when a trig equation says it wants the general solution, what that means is it wants you to find some way of expressing all the infinite solutions that there are. 0, 2 pi, 4 pi, 6 pi, 8 pi, all the way out to infinity. So I'm going to run through this quickly for two of these. You can figure out the rest based on what I'm doing. So sine of omega equals 0. I'm going to make a unit circle. This comes in very, very handy in this unit. So sine of omega, that's talking about the y values, right? That's right here. See, the y values there are 0 on the standard coordinate plane. And I need to find some way of saying the following in a formula. Okay, so I need to say omega equals 0 comma pi. But if you think about it, that's only this far around. And I'm really going around there. So 2 pi, 3 pi, 4 pi, and so on and so on and so on in spirals. So 2 pi, 3 pi, etc. And how do we say that idea of etc. as a formula? Well, you can look through these formulas and see which one matches. That would work. Or you could try to make your own formula based on what the pattern is here. I don't really have any preference. I tend to look for patterns in this list over here and see which one fits. I'm thinking this one looks pretty good. Let's just double check before we put that in. So pi times k. K is any integer. So that could be pi times 0, pi times 1, pi times 2, etc. And that looks pretty good. That's our pattern. Okay, so there's the answer for sine of omega equals 0. Let's try cosine next. I'm going to try cosine equals -1. Okay, and I want to erase some things from this that aren't so useful anymore. Put on, okay, so cosine equals -1. Cosine is my x value. So -1, oh, look, I'm over here. Same spot again. But it's a little different because this time 0 is the solution, 3 pi is the solution, and so on. Sorry, I said 0, but I didn't mean it. 0 is not a solution. Pi is a solution, 3 pi is a solution, and so on. Basically, every time you go around this circle halfway, pi, 3 pi, and so on. So, which one of these things works here? Let's see. You might be tempted to say this one. 2 pi k. Well, try it out. Before you make that your answer, try it out, see what happens. 2 pi times 0. Ooh, that's no good. That's 0. 2 pi times 1. That's just 2 pi. Okay, so this is not working. This is no good. That is not our pattern. I don't like the pi over 2's. I mean, I can see those are clearly just wrong. So maybe by elimination, this one seems pretty good right here. Let's just double check anyway. It's going to be pi plus 2 pi times 0. Well, that's just equal to 1 pi, so that works. Pi plus 2 pi times 1. That'll be 3 pi once you count up all your pi's. Okay, so that works. That looks pretty good. So this is the process you go through here. It should get faster as you eliminate more and more of the choices. We won't ask for general solutions too much. It generally turns into a pain in the butt to keep talking about formulas for your answer instead of just doing 0 to 2 pi. But it is good to know how this works in general.